All right. Let's hit 4.3. This is Thomas's. The math isn't intense this time. It's kind of a light section. It's based on some stuff you know, and even the stuff you don't know is fairly basic. We're doing about 3 or 4 different skills here grouped together. So let's tackle the first one. In Thomas's page, the top of the purse tells you the rules. Don't worry about those. We'll hit them as we go and look at what you're supposed to do. So you can see them on this page. 1, 2, and 3 use the product property. 4, 5, and 6 use the quotient property. And number 7, 8, and 9 use the power property. So we're just going to tackle each one 3 at a time. So let me remind you of something that you already know on number 1. You know that if we have x to the 3rd times x to the 5th, when both bases are matching, you're going to add those exponents. So when this is a multiplication exercise, we're adding exponents. So of course we get x to the 8th. Logs are like that. Remember, exponents, these guys, and logs are opposites of each other. They're inverses of each other. So with number 1, we've got the log, and this is the common log, not that it's going to matter in these, but it's the log of 2 times x times y. So this is the log of these 3 things multiplied together, this product, just like this product we add. So this product, we will separate these out and add them. So this is going to give us the common log of 2 plus the common log of x plus the common log of y. We're going to take each of these this product, and we're going to be able to separate them out and add them together. So when it indicates that you're supposed to be multiplying, we're going to be adding. Just like here, when it indicates that you're supposed to be multiplying, we're adding them together. Now, we're done with number 1, but what you would need to do is see if you could simplify these. Is there a number that you could raise 10 to make them be a 2? No, 2 and 10 are not related to each other exponentially, so we're good there. Is there a number you could raise 10 to make them be an x or a y? Heck no. So the 10 is unnecessary. The 10 would not be part of the answer. That is the answer. Okay, let's look at number 2. We've got log base 2 of 2 times x times y. And so we're going to do the same kind of thing. The product property allows us to separate this product into sums. So we would say the log base 2 of 2 plus, because it's multiplication, and multiplication is the same thing as addition in exponents and in logs, log base 2 of x plus log base 2 of y. And now we need to simplify. What exponent could you use to raise 2 up to a 2? What exponent do you lay on that 2 to make him be a 2? In other words, 2 to what power will give you a 2? And that is a 1. If you're a little weak on that, if you haven't done 4.2, you need to go back and do 4.2. You'll see that over and over and over and over again, that idea. What do you raise a number to become himself? That would be 2 to the first power will give you a 2. So the 1 is the exponent. Remember, with a log, the answer is always the exponent. Here, there's nothing to do here. We can't raise 2 to anything to make him be an x. So log base 2 of x, log base 2 of y, and we're good there. All right, let's look at the last product property problem here. Natural log, no big deal. It's just, it's just a different version of the natural log, or sorry, the common log and natural log, just a different base of 3 times a plus b. Got double sets of parentheses there. Okay, so this is the natural log of 3 times a plus b. So that's the product. The natural log of 3 plus, because this is a product, whenever we're multiplying, we're actually going to add the separated ones out, of a plus b. And that's it. Remember, the idea is, what can you raise e to make him be a 3? And e is like 2.71 and change. There's nothing we're going to be able to raise e to make him be a 3. There's nothing we're going to be able to raise e to make him be a plus b. Leave those e's out. They're just understood. If it's a natural log, the base is an e. Leave those e's out when you are putting it into MyMathLab. And you're not doing these into MyMathLab anyway. This is Thomas's worksheet, but that still, you would not put e's down there. Okay, 4, 5, 6 works on the division kind of idea. So before we look at that, let's look at what you know about division of exponents. If you have x to the 5th divided by x to the 3rd, when it says to divide, you're actually subtracting exponents. Same thing we're going to do with the logs. So let's look at 4, 5, and 6. 4 is log base 7 of z divided by 49. That's going to tell us that we can do log base 7 of 2, and this is division, so we're going to subtract log base 7 of 49. So there we go with that. Now you've got to look and see if you can do some cleanup. Is there an exponent you can put onto 7 to give you a 2? 7 to what power gives you a 2? Nothing. So log base 7 of 2 minus, is there an exponent you can lay on 7 to make him be 49? 7 to what power will give you 49? And that's a 2. Let me scribble up here. Log base 7 of 49 is the same, equal to x, do the circle. 7 to what power equals 49? The exponent would be a 2. So here's the answer. We could simplify this piece because there is an exponent you can raise 7 to make him be 49, but there's nothing happening there. Okay, number 5 and number 6 are similar in that we are going to take what is divided and separate it out into separate logs and subtract those. So number 5 is the log base 7 of a divided by 14. Put this in parentheses also, make it clear that that both parts are being logged. Okay, again, a division problem, so we're going to separate it out and subtract it. Log base 7 of a minus log base 7 of 14. Let me remember, if you think of something I can help you with on this and do it better for you, please let me know. And if you find a mistake, if you find a boo-boo in here, I'd appreciate that also. Okay, so what are you raising 7 to make him be an A? There's nothing you can do with that, so that is simplified. We'll leave that alone. What can you raise 7 to make him be 14? Now definitely 7 times 2 is 14, but 7 raised to some power equals 14. No, that's not happening. It sure feels like it should, but exponents multiply times 7, not times 2 on going from 7 to 14. So we're going to leave this piece alone. We're good there. That's the answer. Let's look at number 6. Log of a 100 over x plus y. Okay, that's a common log. It doesn't have the base written in there, so we understand the base to be a 10 down there. So let's separate that out. This is a division problem. We know we're going to be subtracting them just like we did exponents. So the common log of 100 minus the common log of x plus y. And when you've got more than one guy that you're taking the log of in the same problem, be sure and put them in parentheses. Okay, so this is now we need to look to see if we can simplify. This is the piece we're going to be able to simplify. You know that understood base is a 10. What do you raise 10 to make him be 100? And if you need to, go do this number, equals x, spin it around. So 10 to the x power is 100, so this will be a 2. The exponent you have to lay on that 10 to make him be 100 is a 2, minus log of x plus y, and we're good there. Last property on the bottom of this page for 7, 8, and 9 has to do with the power property. That's the last property we did with exponents. If you have got x squared raised to the 3rd power, this is an exponent raised to the power of 3. you're actually multiplying those. So that's what we're going to do with 7, 8, and 9. We're going to be multiplying times an exponent that our log is being raised to. Let's look at how that works. Let's say number 7, that we've got the natural log. Oh, am I on the screen? Good, just lost you. Let me bring this down. Okay, going back over that, an exponent raised to an exponent, we're going to be multiplying. So anytime we've got some sort of a log raised to a power, we're going to be multiplying this log times that power. So this is the power property. Don't think you need to memorize those terms. You just need to know the function. So number 7 is the natural log of x to the 5th. So we have this natural log of x, and it's being raised to this power, just like this 3 here. This is being raised to the 5th power. So we want to take the natural log of x and we want to multiply it times the 5. So we're going to sling it out in front, 5 times the natural log of x, just like we did 2 times 3 in a sort of similar way. We're going to sling this to the front and say 5 times the natural log of x. Then you're being asked, is there an exponent you can raise e to make him be an x? No, there's not, so you're good here. Let's look at number 8. We have got the natural log of e to the 5th power. Okay, so we're going to take the natural log of e. This is raised to the 5th power. We're going to sling that out in front and put the 5 there. And now remember, natural log has an e as a base. Is there an exponent you can raise e to make him be an e? What exponent do you slap onto e to make him be an e? And so that's like, you know, if we're going to e equals x, sling it around, e to what power equals e? Well, that'll be a 1. So we've got 5 times 1, so we're getting a 5 out of that. We can simplify that quite a bit. Number 9, we've got the common log, base 10, understood there, the cube root of x squared. Okay. You know that if you've got the cube root of x, the cube root of x gives us x to the 1/3. We've done that a bunch with the exponential graphs. What we now have, though, is a 2 right here, and that 2 is going to go up on top in the numerator. So when you're converting a radical, the denominator right here is the index. The numerator will be the exponent that the variable is raised to, or that whatever is raised to underneath the radical. So this is the equivalent of log base 10 of x raised to the 2/3. So the index is still the denominator. What we're raising it to will be the numerator. So that's x to the 2/3. That's one of those things you missed in 0362. Not a big deal. You just got to memorize that pattern and you can handle it. So now we're doing what we did here. If we've got an exponent that we're raising, or that we're raising to a power, this is the exponent we're doing that with, we're going to sling that out in front. So up here, 2/3 times log of x. What can you raise 10 to make him be an x? Nothing. So this is the answer. 2/3 log of x. Okay, let's turn the page over, see what's happening on the next page. Those 3, that's the first kind of thing you need to learn how to do in 4.3. The next thing we're going to do on 10 through 14 is to expand these out. We're going to use these 3 principles to take a log and do whatever it asks us to do, whether it asks us to change a product into a sum, to change a quotient into a difference, or to change a power into a multiplication. So let's play around with that. You'll find this to be less painful than some things, I hope. We've got log base 3 of 5z over w. Got parentheses around that because it's got more than one thing we're taking the log of. All right, let's see what we've got here. This is a multiplication, so we're going to have to say log base 3 of 5 plus log base 3 of z. And then we're going to be dividing, so we're going to subtract log base 3 of w. That's it. So log base 3 of 5 plus, because these are multiplied together. And then we're going to the bottom, so if you're dividing, you're going to be subtracting. And that's it. There is nothing you can raise 3 to make him be a 5. Nothing you can raise 3 to make him be a letter. So we're good there. That's all they need you to do. Number 11, we're looking at log base 7 of AC over 5D. Okay? This is not going to get super complicated. This is very simple. This is going to be log base 7 of A. Then let's bring along C. So it'll be plus log base 7 of C. So log base 7 of A plus, because they're multiplied, log base 7 of C. And then we're going to the denominator, so we're going to be dividing. So we'll be subtracting here, minus log base 7 of 5. And we're going to be subtracting somebody else too, minus log base 7 of D. That's it. There's no more simplifying we can do. Can't do anything to 7 to make him be an A or a C or a 5 or a D. So that's it. Number 12, got natural log of x squared y. Okay, this is going to involve some multiplication, so we'll be adding these two. And then this is a power right here, so we're going to sling that 2 in front. So I think it's easiest probably to go ahead and separate out the two products. So natural log of x squared plus the natural log of y. And then this power needs to be brought out in front. So we've got 2 times the natural log of x plus the natural log of y. There's nothing you can raise an e to make him be an x or a y. So this is the answer. We use the product property to separate out x squared and y. And those will be added together. And then we stuck that exponent out in front to multiply times some power. It's not more tricky than that. And then you look at this next one. We've got the cube root of x squared on top, and we've got w plus z on bottom. All right, we've done both of these, just we've done them up here by themselves. We did natural log of cube root of x squared right up above there, number 9. We've done that with a common log, but natural log, same game. And then we've done the natural log of a sum on number 6. The denominator was this sort of thing. So you've done this. Let's just combine it together. So let's take care of the numerator first. The natural log of the cube root of x squared. And then because this is division, we'll be subtracting it, the natural log of w plus z. Okay, there's nothing more to do to the back end of this. There's no way e can become w plus z. But we've got some power thing going on, or sorry, product thing going on here. Let's simplify this, or let's write this as an exponent. So this is going to be x to the, make a fraction bar. Remember that the index is the denominator, and then whatever exponent is there will be the numerator. So we've got x to the 2/3. Not going to change this piece back here. Sling this out in front. Any power is going to go out in front to multiply times the natural log. We're going to be playing with these properties and using these ideas in section 4.4. So don't think this is one and done here. Number 14. Let's see, we're looking at log base 2 of the square root of 4x over yz to the 3rd power. Okay, let's see what we're going to do here. Let's take this radical and get rid of that radical. So let's put the radical on each piece. So we've got log base 2, and then I'm going to create this monster, the square root of 4, the square root of x, the square root of y, and the square root of z. What was that, a 3? Yeah. Z to the 3rd power. So that's just separating out each of these pieces. And then what we can do from there, let's do some simplifying first. The order doesn't really matter here. I want to clean it up. The square root of 4 is really a 2. The square root of x, we're going to call x to the 1/2. You know that when you've got a radical, turn it into a rational exponent, an exponent that's a fraction. The index becomes the denominator, and there was a 1 there on that x, or just 1/2. Square root of y, similarly, but will be y to the 1/2. And then z cubed. Z needs a fraction bar. The index 2 is the denominator. The numerator will be this exponent. So we've got that mess right now. We've got log base 2 of 2 times x to the 1/2 divided by y to the 1/2 times z to the 3/2. Okay, let's break that out. It's going to be long, so I think I'm going to just move it over here, like that. Log base 2 of 2 plus, because we've got something multiplied in the numerator, plus log base 2 of x to the 1/2. Then we're going to the denominator, so we're going to begin subtracting, minus log base 2 of y to the 1/2 minus log base 2 of z to the 3/2. And this is subtract. You might say, well, these two are multiplied together, but it's a subtraction piece because it's in the denominator. So if it's in the denominator, you want to be subtracting them. It's just memorize it. That's how it goes. Let me raise this up a bit. Good deal. Okay, let's do some simplifying here. We've got to use the property to sling these exponents in front, every one of them. But let's start here. We don't have an exponent to sling in front, but we can do some simplifying here. What is the exponent you can lay on 2 to make him be a 2? That's a 1. We've done that a couple of times this page. And then plus, let's sling this power in front, 1/2 log base 2 of x. Sling that one in front, minus 1/2 log base 2 of y. Sling that one in front, minus 3/2 times log base 2 of z. There's nothing we can raise 2 to make him be an x or a y or a z. So we are done with that one. Let's see what we can do with number 15. Oh, moving to the next page. Okay, so we are done expanding those out. Now what they're going to do is give us the expanded version, and you've got to compact it. That's what they're asking you to do. The instructions say write a logarithmic expression as a single logarithm. So they've given you the expanded version. They've given you what we just did as answers for 10 through 14 and asking you to back up with them. So the original problem here is common log of 4x minus 3 minus common log of x. So what we're going to do there is we're going to notice that we've got a subtraction sign. You know that means that we want to combine these logs, and this will be the numerator, that will be the denominator. So common log of 4x minus 3, it's 2 parts, so I'm going to put a fraction over it, and then over x. Let's make those parentheses over all 3 parts, the 2 terms there and the term in the bottom. And that's it. That's all they're asking you to do. This was a subtraction problem, but it indicates to you originally it was a division problem. Let's see what we can do with 16. We've got log base 2 of z plus 4 times log base 2 of y. The last thing we did when we did these, when we were expanding them out in the previous problems, was to take care of this property by slinging it forward. Let's do that first. Let's sling it back. So we've got log base 2 of z plus log base 2 of y to the 4th. Then this is an addition problem, so that tells us these will both be in the numerator. So let's go log base 2 of z times, or we can leave out that dot, y to the 4th. Put them in parentheses because you want to take the log base 2 of z and log base 2 of y to the 4th. Okay, that looks good. Let's look at number 17. Let's see, we've got 3 times the natural log of x plus the natural log of x minus 2 minus the natural log of 5. You getting all that in there? For sure there. Okay, when we're going to condense these, let's first take care of the powers. So this will be the natural log of x to the 3rd power. We don't have anything more going on. Natural log of x minus 2 minus the natural log of 5. Okay, all these are natural logs, so we can build one natural log thingy. Let's get a great big guy for all 3 of these parts. X cubed goes on top. So does x minus 2. Didn't leave myself enough room there. And then we're subtracting natural log of 5. So try that again. In the numerator, these two are added together. So we're going to have x to the 3rd, and we're going to have x minus 2 up there also. Subtract 5, so 5 will go on bottom. Something like that. Yeah, happy with that one. Okay, let's look at number 18. We're skipping 18. Omits 18. Yeah. So number 18 is an omit. It's too much trouble. If we were in class and we were spending, whatever, we might do this, but I'm not so sure we would. There's nothing like, even remotely like it in your homework. Okay, the last thing that you're responsible for figuring out how to do in this section, in these problems, is what's called change of base. Super easy on change of base. You know how when we have log base 10, that's called a common log, we have natural log, that base is to the e. You can use your calculator for those. Anything else, if we're trying to find, for instance, log base 2 of 7, what do you have to raise 2 to make him be a 7? We don't have a way to do that. We don't have a log key of log base 2 on our calculators. So they've got a rule. Of course, they've got a rule. Let's look at what that rule does. Number 19 asks you for log base 7 of 15. It's asking you, what do you have to raise 7 to make it be a 15? Well, let's look a little bit. 7 to the 1st is 7. 7 to the 2nd power is 49. So we know that our exponent, remember the answer to a log is always an exponent, we know that what do you have to raise 7 to be a 15? It's going to be somewhere in this neighborhood, 1 point and some change. But we don't know what it is without using our calculators, and we don't have a log base 7 on our calculators. So what you're allowed to do is you're allowed to figure out common log of 15 divided by common log of 7. So the log of 15 goes on top with a common log, and 7 goes on bottom. If you're in the mood to use natural logs, you can do that too. Natural log of 15 over natural log of 7 will give you the same answer, and I want to show you that on your calculator. So we'll turn your problem, and you completely get your choice. Do you want to use the common log button, which is the 2nd button down? Or do you want to use the natural log, the 3rd button down? You pick. It doesn't matter, and I'll show you that. But you're going to put log base 10, common log of 15 on top, 7 on bottom. The big number on top, the little number, the base number on bottom. So let's attack this one. Common log of 15, close that out. Otherwise, you're doing some weird thing of 15 log 7 on the top, and you don't want that. So log of 15 divided by common log of 7 equals, and that gives us 1.3917 when you round to the 4th place. It's a 167 round up. Same thing's going to happen if you use natural log. So natural log is this key. Natural log of 15, don't forget to close it out with the other set of parentheses, divided by natural log of 7, and you get the same answer, 1.39166, which rounds to 1.3917. So you're going to get that same answer. Sure enough, it's a little bit more than 1. 7 to the first gives you 7. 7 to the second is too big. We're just trying to get to 15. You can test that out too. You can do 7 raised to the 7 humpy, 1.39166, I remember it being. And there you get almost 15. We left off some, so that's why we're a little bit shy of 15. Okay, let's look at number 20. Number 20 is asking you to find the log base 5 of 0.3. Okay, so we want to raise 5 to some power to make it be 0.3. 5 to the first power, that's too much. 5 to the 0 power is a 1, we're getting there. 5 to the negative 1 is 0.2. Well, it's 1 over 5, which is 0.2. And so 0.3 falls somewhere between in here and in there. So that's where we're going to end up. We're going to end up somewhere between a 0 and a negative 1. 0 is too much. Negative 1 is only 0.2. We're going for 0.3. Okay. So what we're going to be able to do then is do log of 0.3 divided by log of 5. You can do that. Or you can do, my earphones just did something funny. Okay, I think I'm back. I don't know why my earphones did something funny, but anyway. Natural log of 0.3 over natural log of 5. Either one of those will get it done. So log of 0.3, close it out, divided by log of 5 equals negative decimal point 7481, rounded to the 4th place. And sure enough, that's between 0 and negative 1. It's not quite negative 1, almost though. And then if you use natural log of 0.3, close it out, divided by natural log of 5, and that gives us the same answer exactly. If you want to check it, you can raise 5 humpy negative 0.77481 equals, and there we get almost 3, just barely shy of 3 because we lopped off some of that answer. Okay, we're good. I'll see you next time for my version of 4.3, which would match my math lab.